Welcome, everybody. Good to have you. Today we're going to have our very last session. It's been 2 months. We've covered lots of things. Today we have 2 more topics. First one is right angles and trigonometry, and the last topic is circles. They are relatively easy topics, so I don't think this will require too much effort from your side today, at least. So that's good. I think we can start with the questions. I think you had some problems with one of the medium questions.
Kind of just all of them. I mean, I don't really remember a lot of how to solve these. I recognize some of them and what I need to do, but I don't know. I feel like I just need to be caught up again.
Yeah, of course. So we can do a quick tutorial in right triangles. So right triangles have been the interest of the Pythagoreans. They're mostly the ones who developed this field of mathematics. Very interested in right angle triangles. And rightfully so. They are, I wouldn't say very interesting, but they're somewhat interesting objects, at least for the time. Pythagoreans were they see, I don't know. But like at the time, this was very, very advanced, cutting edge research. So you would have a right angle triangle. We know this is 90 degrees. Then, if this angle is some angle, which I'll call theta height, it's good to see. And then, if I choose another angle here, then the sum of these 2 angles must add up to 90. This is obvious. They were like, okay, can't really do much. They also proved the Pythagorean theorem, which we talked about last time. That's a nice proof. But it just says that if you take this side and square it, and add it to the length of the other side and square it, you get the square of the third side. And then they said something that was very interesting. They said that any right angle triangle can be identified and characterized by the ratios between its sides. And this is very interesting because if you don't know the angles that you have here, you don't need to worry about it, so you can always retrieve them. If you know the ratios between the sides, you should be able to retrieve the angles. And this is a very interesting idea. So let's say I have this as a triangle 3, 4, and 5. I'm just applying the Pythagorean theorem. Then I can find out what this angle is, and I can find out what that angle is just by knowing the sides. So this is also very powerful in this sense. I'm trying to motivate theory here. And let's see what this characterization looks like. So if I take the exact same triangle again, I think I forgot to. Anyway, take the exact same triangle. Paste it here. So I'll define some ratios, some trigonometric ratios. I'll just need to talk about theta because in the end, alpha is just 90 minus theta. We talked about this because the sum of the angles needs to be 180, and we already have a 90-degree angle. So what I would like to say is it is sufficient for us to just study this angle. And to look at the ratios. And they are defined as follows. So we have something called the sine ratio. So we define the sine of an angle theta to be equal to A over B. So it's the opposite side divided by the adjacent. Oh no, sorry, that was a big mistake from the start. I want to start discussion with a mistake. It's not good. And so A over C is effectively just saying the opposite side, theta, divided by the hypotenuse. The hypotenuse is the longest side in the right angle triangle, or you could say the side that is right in front of the right angle. You know, right in front of the right angle. That sounded funny. Anyway, and we could also define something called a cosine. So you could think of it as the cousin of sine. And it is not the opposite divided by the hypotenuse, but it is the adjacent to the angle theta divided by the hypotenuse. You could say it's not the opposite. So the angle that's not the opposite is actually just this one. So it's not the opposite, but it's at the same time not the hypotenuse. So in this case, you just get B over C. And then this is all you need. You could define also something else called the tangent function. Well, it is a function, but I don't want to talk about that just yet. It's just a ratio for now. You could define it as sine of theta divided by cosine of theta, which is effectively, I would multiply, not multiply, I would divide sine of theta by cosine of theta just by the way I've defined it. If I want to divide this, then I probably should multiply the inverse fraction. And something very nice happens, the hypotenuse cancels out, and it's just the opposite angle, theta, divided by the adjacent angle, theta. So these are just some formulation, and there's nothing really interesting here. But these are the basics that should get us going. I'll copy them, put them in a nice box, and then I think we can start. And if we need to add more things, then we'll do just that. Here's my nice box. You think this is a nice box? It's good. Yeah. So we take this, for example, and here there is a, I don't want to say a simple question, but I would say a direct question. If you use your tool set, and the question is, what is the value of tangent of A? Now, please note that this tangent A, angle A, is the one that's right here. So what is the tangent of this angle? This is a question for you. Hi, it's good to see you. It's a question for you guys. You know the answer? You can just say
20 over 21.
20 over 21. Because you take the opposite, then you divide by the adjacent. Okay, that's easier, right? It's not too difficult.
I think once you have that box, you're kind of good.
Yeah.
It's just I didn't remember that exactly. So doing these problems is a little impossible.
Yeah, I understand, but here's how I did it. So when I first learned these things, I'll tell you this, I didn't really completely understand what they were. I didn't really understand what they were doing. But I was like, okay, this is the formula. This is where we at. This is where we need to go to. I'm just gonna apply the formula and get the result.
Yeah.
And this is, I mean, for my, for when I studied this for the first time, I think it was very effective. So this is precisely what you need to do. And then now let's take this exercise. This is not an exercise about trigonometric ratios. Maybe you think about it for a moment. I wouldn't say it's too difficult in particular. So if you know the answer, you can just shoot it. It's fine, you're still online.
Oh yeah, no,
No, you're still here. I just exited right now. I was looking at you still.
isn't like A equals 6 squared,
No.
I mean A
And now,
squared.
looking at this, what's the first thing I should do?
Okay, well, that's good. So this is something we've discussed previously in the previous class, but also I just mentioned it right now. So it's the Pythagorean theorem. Can you think of the Pythagorean theorem? I'll copy it for you if you don't see it.
Okay.
And I'll remove the angles because in this case they're not interesting. So what do you think that the answer would be?
No, this one.
21 is C, right?
21. Well, yeah, it's the hypotenuse, right? It's the side that's in front of the right angle.
So C and no.
You need to write this down. So let's apply the Pythagorean theorem.
21 equals
That's
6 squared plus A squared. Then we solve for A.
Yes, 21 squared
Yeah, equals
equals
6 squared plus A squared.
6 squared plus a squared.
Then we solve for.
Yeah, exactly. So here's all you need to remember. All you need to remember is that if you square the hypotenuse, you get it is equal to the sum of the squares of the other two sides. So the square of the hypotenuse is equal to the sum of the squares of the other two sides. So you take the other two sides, a and 6, you square them, and you square 21 on the other hand. And now your goal is to find a. Well, you can find a squared first. So it would be 21 squared
Minus 6.
minus 6 squared. Then in this case, your a could be both positive or negative.
So yeah, it's B.
21 squared minus 6 squared. I say positive or negative for the sake of completeness. Think about it for a moment. If it were negative, you square it, it becomes positive. But we eliminate the negative one because there's no such thing as negative distance.
Equals B.
I hope I'm not hand waving this.
No, I understand it.
Yeah, it's clear, right? Well, I didn't hand wave it, but I was speaking very quickly. I hope this was clear.
I got a similar question. But
You have a similar question.
no, yeah, I had a similar. I just solved it. That's why I could.
Ah, okay, that's good. That's good. I also had a similar question, but I don't know how many years ago.
When did you take your SAT?
Huh?
When did you take your SAT?
I think it was, I don't know, 4 years ago or something. It's a long time. Good days. Anyway, so this is another problem, and I will tell you this. We will use our toolbox, but this will require a little bit more creativity. So my advice for you is to start with your tool set, try to apply it to the information you have, and then finish off the problem.
Is the medium or hard question?
This is just a medium question. because I felt like there was some background information that was missing, and this is why I started with the medium questions. So I always use the first 15 minutes of the session to determine if we need to do more difficult questions or more easy, depending on the audience. This happens in the case of a right angle triangle. The best thing you would do is you would start drawing separate triangles, or maybe you don't need to draw separate triangles. But here you have two right angle triangles, so probably do something. The goal is to find AD. Maybe try to think about it for a moment. I'll stop.
Well, A equals 60 degrees.
A equals 60 degrees. That's progress. You see why?
And also the other side of B, just
Yeah, that's very good progress. 60 degrees. And this is 30. But can you tell me why?
with in a triangle, the sum of all angles equal 100.
Okay, let's go. This is 90, this is 60, this is 30. Okay.
So now for all of the angle A, B, C, for C it's 60 degrees, and for A it's 60 degrees.
Okay.
So,
Yeah, that's good. So you know all the angles, not all the sides. So if you know the angles, you know one side, you can start talking about ratios. And there's your toolbox.
and also you can clearly see that the side AB is also 12.
Side AB is also 12.
Yes.
Can you tell me why?
Because they have the similar angles.
You mean the similar sides?
Similar shaft.
So if the sides are the same, the angles are the same and vice
Yeah.
versa. We did this last time. Okay, this is also good progress, sure. Then probably this is, what is the length of AB?
But
Okay, that's very good.
well, now we have 12 and 12. Yeah, we have hypotenuse and we have
So I would invite you to look at the triangle ADB,
Oh,
which is this one.
okay.
Okay. I'll just copy whatever is in there. So this is 60 degrees. This is 30 degrees. This is 12. And this is our AD that we need to find. Now, my tip for you would be to choose a trigonometric ratio, which includes what you know, which is the hypotenuse, and what you don't know, which is what you need to find. It's AD.
Actually, it's actually 10 answer.
Sure, but you need to tell me how you got it.
Yeah.
So which trigonometric ratio of which angle here would capture AD and also capture AB?
It's the answer is C. Six.
Can you tell me why?
Because actually we have the same angle, so obviously it's the same size. If it's the same angle, so it's the same size in this triangle because they are equal. It's actually the triangle is equal 180, you know. And actually, if it have the same angle, that doesn't mean that the lines is the same length.
Okay, so you did something that's entirely different here. So
Yeah.
you're saying that the whole triangle, here there's an angle of 60, because it's 30 and 30.
Yeah.
And here there's an angle of 60. Here there's an angle of 60.
Yeah. So if
The sides are equal,
the sides are equal.
the angles are equal, and vice versa.
Yeah.
And this is 12, this is 12, and this is 12. But how do you know that this line divides AD and DC? You can't really show that without using trigonometry. So it is correct.
It's
If you're
actually
the
sounds-
exam-
if you see it, as I see it, if you see it, it's like actually like it's like you see it like from here it's actually 90% and 90%. And here 16, here 16, here 30, here 30. That's obvious.
So that makes it divide because
If they are equal, the angles are equal.
So you're saying it's because these two triangles are exactly the same.
yeah.
So if they are exactly the same, this is 30 degrees, it's 30 degrees, 90, 90, 60, 60.
So
Sides are the same.
so
then-
same size.
Then this should be divided. Then
Yeah.
this whole thing is 12. And-
A to C it's 12. So
Yeah, and it should be divided between these two.
The line evenly splits divide the angle.
Okay, that's a good option. So you need to make lots of observations for this.
There's like a trick in the set. If they give you a triangle and they didn't write under it, then the sides are not really wide.
Then you can use this.
Not that they're not. It can just use a ruler for the
Yeah, sure.
Just draw a line on the paper and measure it on the screen.
Sure, but that would take you time. That's not really the way we're trying to approach this.
It's literally faster than
So I'll agree with you that the answer is indeed 6. But I would still try to encourage you to use this tool set. I think it's very important to try to use.
Could you also solve it the way you were?
Use two of them. Yes, we will do that now. So here's what I mean. So this is our triangle. We know the hypotenuse. So probably we'll choose either a sine or a cosine. Doesn't matter. So we'll choose sine or the cosine of something. It will be something divided by the hypotenuse. I'm just looking at this, okay? Which one is it? Well, choose whatever you want. Do you want 30-degree angle or do you want a 60-degree angle? Which one do you like more? 60. Okay. Then, oops. Then here's the tricky part. Is this side AD? Is it opposite or adjacent to 60? Adjacent, right? So if it's adjacent, then you should take the cosine of 60.
Yeah.
Okay, you take the cosine of 60, you take the hypotenuse, and then it's AD. And guess what? Hypotenuse is the largest side in the right angle triangle. It's always the side which is right in front of the right angle.
So it's 90.
No, that's the degree of the angle.
Oh,
The
okay.
side which is in front of the 90-degree angle. That's the hypotenuse.
Yeah, it's a sine for it.
Yes, that's good. So here's what we can do. We know the hypotenuse is 12. We don't know AD, but there are good news, which are that we can actually compute cosine of 60. You can use a calculator if you don't know what cosine of 60 is. I think it's going to be a half. I don't know this because I'm a human calculator. I've just seen it so many times, so I know it, but I don't memorize cosine.
So I'll take 0.5.
Well, at some point, there's only so many degrees, so at some point, you.
Yeah, I know. At some point, there's infinitely many degrees between 0 and 90, and just get to know them all. So that's it's interesting. This is half. Cosine 60 is half, and 80 over 12 is half. So you just, AD is just half times 12, 6, right? Quick maths. So that's something difficult. That's another way you might obtain the answer. I think it's a good idea if we do one more. I just want to make sure this is solidified. But I really want you to focus on how we approach this. So we chose this two sides, choose the hypotenuse because we knew it. So we chose the AD side because we didn't know it and we wanted to know it. So you have to make the right choice. And you have to make the right choice to the right angle. So here we had the choice to choose whatever angle we wanted, but you could have just proceeded like this. So if this is 30 degrees, then you take the sine of 30 degrees. It's AD divided by 12. Yes, you need to work for the fact that this is also going to be 12. It's a good observation. But then you will get that sine of 30 is equal to AD divided by 12. It's the same result. So in short, cosine of 60 degrees is the sine of 30 degrees. And more generally, if we think about this for a moment, the sine of theta is equal to cosine of 90 minus theta. Because if you're in the triangle, just giving you insight, you don't need to memorize it. Ah, this was a nice triangle. This is 90 minus theta, and this is theta here. And if you take the sine of this, it's the opposite divided by the hypotenuse. And if you take the adjacent of this, the cosine of this, it's the adjacent divided by the hypotenuse. So they're the exact same thing. That's what I'm saying, generally. But I'm hand waving this because we don't really, we don't absolutely need this piece of knowledge. I'm just giving you more insight. So this is a good problem. I would suggest you grab your pen and paper / pencil and start drawing some triangles. I think I'm going to do some certain problem. Remember the problem that we did? Yeah. Second scale because of talking here. Another question?
Yeah, that's it.
Yeah. Is the whole scale also so?
Yeah.
Okay, I enjoy that.
Each time I do a practice, there is a circuit question. Today or today.
Yeah, it's the full scale inclusive.
Whatever discovered, you can do it with this.
Ah, okay. Maybe for the last part we do.
Yeah, but
Yes.
some of them you cannot do it.
Ah, okay. That's a shame.
In the way. I got many questions in the practice.
Math question. If you have some, we can talk about them after.
I think in the module 1 of math, maybe I got all of the questions right. On the second one,
Because it's adaptive.
yeah,
But I think that's good.
like 6 questions in the second module, I just guessed.
I think that's still good. Like if you do.
Yeah, I did the hardest practice that it is 5. I got 1,150.
No, but it's good. It's in the right range that you would like to have. So I want you to first notice that this is a rectangle, but do not be phased because the rectangle is just 2 triangles stuck to each other and flip 90 degrees. Right? I just take this triangle, I clone it, and then I flip it and glue it back again. The length of the rectangle's diagonal is 5 square root of 17. And the length of the rectangle's shorter side is 5. What is the length of the rectangle's longer side? Maybe I'll copy what as well, just in case you need it. So what is the length of L?
L?
The longer side. The shorter side is the longer side.
Should be the root of the time square.
It should equal 5.
Yes.
What is it? What did you name it? L?
I named it L.
It's L squared equals 5 squared plus 5. Oh no, that's not okay. So that's 5 radical 17 squared equal 5 squared plus L.
You mean square root of 5?
Yeah.
What do you?
From the hypotenuse.
We don't want the hypotenuse. We want the.
Yeah, I know, but if you want to get this, it's the.
So if you want to get 5 square root of 17,
Yeah,
it's equal to 5. Well,
5 squared plus.
5 square root of 17 squared.
Yeah,
It's equal to what?
5 squared plus L squared.
5 squared plus L squared. This is just directly applying the Pythagorean theorem.
The L squared because negative 5 squared.
Then you just take the square root of 5 square root of 17 squared minus 5 squared to get L. I did this in 2 steps.
What? Why there is no radical for all?
Because I can find L squared,
Oh, okay.
but I need to find L. So to find the L, I take the square root.
Yeah,
Let me write this.
that's good.
If I just write the square,
Then we can remove.
yeah. Just do it like this. No, this is not correct. No, this doesn't cancel out. Sorry. This is just L squared, and I cancel out the square with the square root. This is correct. So again, that L is this thing. You can use a calculator. So you take the square root of 400, I think it's 20, and that's your answer. So you see, it's tricky. You might choose 400 if you do it. We don't want the squares. We want the square root of this difference of squares. So this is very important.
So it's not from. So it's not from.
It's not 400. 400 gives you the square of the side. 400 is this value without the square root. So this is precisely what I wrote here. But if I take the square root,
Yeah, 400 is the value for L squared.
yeah, exactly. Oops, okay, I'll just take a power of half. Don't believe me, I'll give you 20. That is really just how it is. It's just a Pythagorean theorem. I would even argue it's the exact same problem we did here. It's the exact same problem. Are there issues with this lesson?
I was just plugging it in and wasn't getting that, so I don't know what I was doing wrong, but
Let me take a look at it.
it's probably something with the calculator. I don't know. It's okay. I understand how you got there. I was getting to the same thing, but when I tried to figure out the answer, it was giving me a decimal. So
Maybe that's weird. I think maybe because you didn't square 5 square root of 17. Maybe you just squared the square root of 17. You wrote 5 times 17. Because this could happen. You need to take 5 square root of 17.
Yeah.
You square the whole thing. Maybe you didn't do that.
what should that equal?
Take 5 square root of 17. And you square it. Then you take away 5 squared. And then you take the square root. Yeah.
Oh,
What was it the mistake you did?
well, I was just entering it wrong. Yeah,
Yeah, you need to be careful because if you do this, so here's the thing. So if you just write 5 square root of 17 squared, it will only compute the square on the square root of 17. It's
not
very
the
important.
square root.
So you get 5 times 17 minus 5 squared. I don't know, this will be 5 times 12, 60. Then the square root of 60 is something that's ugly.
There's usually always two of the multiple choice that are completely off.
I can't really say for sure. Can't really say for sure. I would even recommend that you do the problems without the choices.
So like not look at the answer.
I would even recommend that, yes. Sometimes, in some cases, it's important that you are able to do drill completely on your own without, needing to look at the answer. But that's just my opinion. Some exercises can only be solved by using the choices. So it's you need to find a balance. Do we want to do one more problem? I think this is a good problem. This is the last problem we'll do. And for this one, we just need so I'll tell you this. You'll need to use one of the three. Well, usually you don't use the tangent function because usually, okay, no, you might need, I don't know. This is for you. Question for you. Try to solve. I think it's really annoying. The hypotenuse is the biggest side of the triangle.
Yeah, it's right.
Huh? Is it 8?
Yeah.
How is it 8?
What do you
The biggest side of the triangle.
8 is the biggest side of the triangle. Yes, that's 100% correct.
Okay.
Which is what? Is it big?
Opposite is opposite of the
Yeah.
30.
So what's opposite to the 30?
That's opposite.
So we opposite to the 30 is what we want.
Okay.
Okay, and what do we have?
Yeah, the hypotenuse.
Okay, that's good. So we should take the one that combines the hypotenuse and the opposite angle,
Okay.
which is
8 and 30.
the one that combines the opposite and the hypotenuse.
Sine.
Sine. Okay, so sine of what?
Theta.
Theta. And in this case, your theta is
30 degrees.
30 degrees. This is equal to the hypotenuse, which is
Opposite, which we don't know.
no, we know the hypotenuse.
We know, yeah, 8
And the opposite side,
and
PQ?
yes.
Q. Okay.
And this is an equation in one variable which you can
Yeah,
solve.
angle Q is 60 degrees.
Of course. So PQ is going to be 8 sine of 30. Sine of 30 is also a half. It's cosine of 60, the one we did before. So this will actually be 4. But I mean, if you don't believe me,
Is that it? That's
yeah, that's it. That's just that's a 4.
straightforward.
Yeah, I would say that, but you just need to know the ratio.
I need to know.
That's right here. You're saying?
I need to memorize just to remember the sine, cosine of tan.
Yeah, probably.
Because I want to write it down in the beginning of the exam.
Yeah, I wouldn't say you should write it. I would say you should solve enough problems that you don't really need to look at it anymore. This is how I would personally. This is how I personally learned it. I did so many problems with this thing right in front of me that I no longer need to look at it and say, what is this? What is that? So it's just a matter of getting used to the thing. It's a matter of doing it multiple times. This is how you reach mastery. So that's good. We did all the.
In the right triangle, always
What is it called?
the adjacent is always half of the hypotenuse.
That is only true in the 30-60 degree angle. And if you talk about the adjacent, you need to specify which angle.
Oh, yeah.
In the 30-60 degree, 30-60-90 triangle, this is true. But you need to choose the smaller smaller angle, which will always be 30. So this is something you could say, yes. But generally, as a rule, it's not the case. Is this good?
Yeah, again, something's happening with, I don't know if it's something going on with Desmos or what, but it looks entered correctly to me, but it's not.
Ah, okay, this is very good. This is a very good point to stop and say something. So, okay, this is good. So there is something that might happen if you plug this into Desmos. So there is an angle in degrees this is 30 degrees. But there's also something called a radius. So what is a radian? They say, let's take a circle which has a radius of 1. Right? And can you tell me what what the circumference of this circle should be? No, the circumference. Circumference is the outer fence that you have on the. So it's the boundary. What's the length of the boundary? It's usually if you have a circle of radius r, the fence, the fence is usually 2 pi r. But here the radius is 1. Right? So it's just 2 pi. Now, I think it was some physicists, I'm not sure, but some physicists came along and they said, we don't like the degrees. They're very unnatural to us. We'll make something that's nicer. We'll make 100 degrees, 180 degrees, which is, half a circle, be equal to, pi radians. So it's the angle. So pi radians is the angle you would take in a unit circle so that you get pi as the fence, you could say. So if the length of the arc, basically. So this is an arc. So if I take an arc which has length, which has an internal angle of 180 degrees, I get pi radians. And then they were like, okay, and if I take, let's say I take, a cross section, so say it's 30 degrees. Then I divide this 30 degrees by the 180 degrees. So it's a chunk out of the 180 degrees, and I multiply it by pi because with this very specific ratio. So if this is true, so pi radians, then I can divide by, if I want to get 30, I need to divide by, I think, 6. Right? And then if I do this, I get 30 degrees is equal to pi over 6 radians. And now if you plug into your calculator, well, my calculator is normal. It uses degrees. But if you are on decimals,
I found it. There was a setting to change to degrees over radians. So
so you need to make sure you know this to distinguish between these two.
So I guess if it comes up as a weird number like that, just be like, oh, it says radians, not degrees.
Or you could just change it to degrees and not worry about this.
He was asking about how the algorithms working, then how the level of hardness for the model 2 depends on model 1.
You're saying depending on how you answer your first section of the math exam, gonna make the difficulty level second.
Yeah, it just makes it more challenging for you, and it's good. But it's good.
Talking about the real exam.
Yeah, so the real exam is adaptive. We can talk more about this after class. We're almost done. But yes, the exam adapts what you did in the first part and Pixel does in the second part. The blue book depicts just that. It provides you the exact same environment here. So that's good. We can now conclude our discussion of right angles in trigonometry.